So the first thing we have to do in order to find these two angles is what is the relationship between the two of them? Are they equal to each other? No. Do they add up to a specific value? They add up to 180. Good. So we've got 3x plus 7 plus 11x plus 5 has to equal 180 degrees. We could have put the 11x plus 5 first, wouldn't have mattered. But after this next step, we'll come out to the same thing either way. So here's our equal sign. Let's combine everything we can on the left side. What can we combine there? 3x and 11x, which is going to make 14x. Anything else we can combine? 7 and 5 makes 12. So we've got, perfect, we subtract 12. 14x equals 168, and then we divide by 14. So x equals 12. All done? No, we're not. We still have to answer the question. The question was, what is each angle? So we've got to come back and put 12 in for x in each of those. So 3x becomes 3 times 12 plus 7. So yes, 3 times 12 is 36, plus 7 is 43, good. So that's 43 degrees. 11x becomes 11 times 12 plus 5. 11 times 12 is 132, plus 5 is 137. Now I'm going to just double check. Do those add up to 180? Yeah, they do. So that's it. Those are my two angles. Any questions? Okay, I'll keep it up there for a minute. Okay. Today, we had a couple of things we want to explore. We need to look at the powers with our variables a little bit more. And we want to look at some things that people struggled with on the test a little bit. And then we'll get into some stuff to prep us for what we're going to talk about tomorrow. So let's look at our powers. We've talked about the fact that x to the third power means 3 x's multiplied together. If I have x to the third power times x to the fifth power, what does that give us? X to the eighth power. Good. Because what we have here, x to the third power, as we said, is 3 x's multiplied together. X to the fifth power is 5 x's multiplied together. If I multiply them together, now I have a total of 8 x's multiplied together. So the shortcut is we can just add the powers. No, we're multiplying the numbers, but the powers add. We'll get to that. Yes, there is a case where you do multiply them. Yeah. So if I had y to the 7th times y to the 11th, I'm going to get y to the 18th. What if I have z to the 5th times x to the 9th? I'm going to get x to the 9th, z to the 5th. When we're looking at these exponents, there's two parts to an exponent. Bless you. There's two parts to an exponent. There is the base, and there is the power. So the base is this number here on bottom. The power is that what most people think of as the exponent itself. That's the power. In order to combine the powers when we're multiplying or dividing, we must have the same base. Z and x are different bases, so we cannot add those powers. Now, why did I change them and put the x first? Yeah, it's just mathematical grammar. It wouldn't, if you had z to the 5th, x to the 9th, that's not wrong. It's just mathematical grammar as you try to put the variables in alphabetical order.
What if you had x to the 5th plus x to the 4th?
Okay. X to the 5th plus x to the 4th. We can put a number up here. Let's just do like 7 and 3. Can we add those? Well, when we add, we must have the same name. And if you look at variables with powers like that, think of cubic inches cubed and inches squared. Are those the same thing? Well, a cubic inch is a unit of volume. It's actually a little box that's 1 inch by 1 inch by 1 inch. A square inch is just a surface. It's just literally a little square that's 1 inch by 1 inch. So they're not the same. An inch squared is 2-dimensional, an inch cubed is 3-dimensional. So if I had 8 cubic inches plus 7 square inches, I can't combine those because they're different things. So the same goes with other variables. X to the 5th and x to the 4th are different names. So we cannot add or subtract them. So remember, when we add or subtract, we must have the same name. If this was 7x to the 4th plus 3x to the 4th, now they do have the same name, so I can combine them. Now remember, adding or subtracting, we have to have the same name, but also, once we add the counts, what do we do with the names? 7 and 3 becomes 10. Will this be x to the 8th? Say no. It'll still be x to the 4th. Because when we add or subtract, we keep the same name. So remember that rule. Add or subtract. Rule number 1 is we must have the same name. So that's why we could not combine x to the 5th with x to the 4th. But we could combine x to the 4th with another x to the 4th. The second rule is in our result, we keep the same name. So that's why x to the 4th plus x to the 4th gave us an answer that's still x to the 4th. When we multiply or divide, our rules are, 1, we do not need the same name. That is why we're able to take something like x to the 7th and multiply by x to the 3rd. They're not the same name, but when we're multiplying, we don't need the same name. When we multiply or divide, we're going to also combine the names. So that is why when we multiply here, we're going to take the x to the 7th and x to the 3rd, and we're going to combine them to get x to the 10th. Now we can throw numbers in there like 9x to the 5th times 3x to the 12th. Now this is where it's tricky. So many people get stuck in, oh, when we multiply, we add. Well, you gotta be careful. We are still multiplying. So this is multiplication. We combine the counts. We're multiplying, so we are still going to combine the counts with multiplication. So 9 times 3 is what? 27. Then we also combine the names. So we multiply x to the 5th times x to the 12th, we get x to the 17th. Because when we multiply variables with powers, the powers get added. Again, we are still multiplying, it's just the appearance is that the powers are being added together. So I might have negative 5, x to the 3rd, y to the 8th, times 7 x to the 5th y. So I'm going to combine the counts. Negative 5 times 7 makes negative 35. So we're combining the counts, multiplying negative 5 times 7 is negative 35. Now we have both x's and y's here. When we combine the names, we can actually, when we multiply or divide, we can take each name separately. So I can do x to the 3rd times x to the 5th is x to the 8th. Y to the 8th times y? Y to the 9th. Good. We treat this as y to the 1, so 8 plus 1 is 9. Any questions there? If we're dividing x to the 5th divided by x to the 3rd, well, x to the 5th is 5 x's multiplied together. X to the 3rd is 3 x's multiplied together. That's what happened there. If we're dividing, you can think of it like canceling. We can cancel out an x, another x, and another x. We're left with just x times x, which is x squared, or 2 x's, which is x squared. So exactly, yeah, when you're dividing, the appearance is you just subtract the powers. 5 minus 3 would give us 2. So if I had y to the 12th divided by y to the 8th, that's going to give me y to the 4th. 12 minus 8 is 4. So p to the 9th divided by m to the 3rd is, you got it, p to the 9th over m to the 3rd. I cannot combine them because they are different bases. I still have to have the same base to my exponent.
We have this on a test, like that kind of problem.
You would just rewrite it like that and leave it.
You don't just leave it blank.
Nope, you don't just leave it blank. You just rewrite it and leave it. Or if you just circled that, that would be fine too. I say leaving them blank worked for you last time. Sorry, that was mean. I know. So z to the 12th divided by z to the 3rd is z to the 9th. If we throw numbers in with them, I might have 12 y to the 8th divided by 4 y squared. Perfect. We are still dividing, so we do combine the counts with division. 12 divided by 4 is 3. And then when we divide the names, y to the 8th divided by y squared, the powers get subtracted. It is y to the 6th. Perfect. So if we have 36 x to the 12th, y to the 3rd, divided by 9xy squared. We combine the counts. So 36 divided by 9 is 4. X to the 11, good. We think of that as x to the 1, so 12 minus 1 is 11. And y, just y. 3 minus 2 is 1, so it's y to the 1 or just y. Not so bad? We will spend more time with those as time goes on. I do want to review something like this. Similar to a problem you had on the test, only with more powers to it. Looking at this, whenever we see parentheses, it should always draw our attention there first. And we have to ask ourselves, remember, there's two questions. The first one is there anything that needs to be done inside the parentheses? Can I combine 4y to the 6th plus 2y to the 4th? No, it's addition, so they have to have the same name, and in this case they don't. So there's nothing we can do inside the parentheses. Someday when you rule the world, you can invent your own type of math and make everybody do it. So there's nothing we can do inside the parentheses. The second question is there anything that needs to be done to the parentheses? And that would be the times, not 5y to the third, but negative 5y to the third. That minus goes with the 5. Then you might say, well, there's subtracting 7y to the 9th over here too, but order of operations says you have to multiply before you can add or subtract. And this is being done directly to the parentheses. So we have to multiply by it. So we're going to distribute. Now we can only distribute with multiplication or division. We cannot distribute with addition or subtraction. So we're going to distribute the negative 5y to the third times 4y to the 6th is there we go. Negative 5 times 4 is negative 20. Y to the third times y to the 6th. We add the powers. 3 plus 6 is 9. Negative 5y to the third times 2y to the fourth. Negative 10. Y to the 7th. Very good. Negative 5 times 2 is negative 10. And y to the third times y to the fourth. 3 plus 4 is 7. Now we still have the 8 y to the 7th up front. And a negative 7 y to the 9th back here. And we do still have to combine what we can. Now we can only combine things that are the same name. Only combine like terms. Is there anything that is like the 8y to the 7th? Yeah, negative 10y to the 7th. 8 and negative 10 is negative 2. Very good. Negative 2. Is that y to the 14th now? Still y to the 7th. When we're adding or subtracting, we keep the same name. Then we've got the negative 20 y to the 9th and negative 7 y to the 9th. Makes negative 27 y to the 9th. What I have written here is a perfectly fine answer. However, we mentioned that math grammar before where we tend to put things, the variables in alphabetical order within each. We also tend to do something called descending order. And what that means is we put the digit with the highest power first. So the negative 27y to the 9th would go first, then the negative 2y to the 7th. It would not be wrong this way, but this is just more grammatically correct. You can. Easiest way to think about negative powers is, let's say we got 10 to the third. Is 10 times 10 times 10, or 1,000, right? 10 squared, 10 times 10 is just 100. 10 to the power of 1 is just 10. So think kind of like what we did with negatives when we were multiplying. You look at the pattern. The power here is going from 3 down to 2, 2 down to 1. So the next step, the power would go down to 0, right? We reduce the power by 1. The result here each time is being divided by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. If we divide by 10 again, what do we get? What's 10 divided by 10? 1. So 10 to the power of 0 must be 1. In fact, anything to the power of 0 is 1. Which is something to note. We'll talk about that again more. I mean, that's not something that's going to appear on a test right away now. We'll go over powers again before it would. But if you knew me at all, you know I have a very twisted sense of humor. And as my students, your mind is my favorite toys. So I may at some point on a test or quiz have a problem that looks something like this. What's that equal?
1.
1. Why does it equal 1?
Because it's all parentheses to the power of 0.
Yeah, anything to the power of 0 equals 1. There's a reason why I stand at the door and listen for revving engines in the parking lot before I leave at night. So anyway, to keep answering your question here, if I keep going, if I reduce that power by 1 more, from 0 to negative 1, I still have to divide by 10. What's 1 divided by 10? 1/10. If I go down 10 to the negative 2, dividing by 10 again would be 1/100th. 10 to the negative 3 would be 1/1000th. You'll notice a connection between the negative powers and the positive powers. 10 to the positive 3 was 1,000. 10 to the negative 3 is 1/1000. Yep, and technically the negative power is a reciprocal. So it's 1 over the positive power. That is something we'll cover more later. That wasn't a topic for today, but I wanted to answer your question. It was a great question, and we will see it again later. So if that didn't totally sink in, don't worry about it. It will come back later. That wasn't a threat. Just telling you. We're going to shift gears a little bit now, then, and we're going to talk about some stuff to prepare us for tomorrow's class. We're going to talk about divisibility. Divisibility means it divides without a remainder. So I might ask, is 36 divisible by 4? Well, if I divide 36 by 4, do I get a remainder? No, I get 9. I get a whole number. That's another way of defining it, is it divides to get a whole number result, or an integer result. But if I were to ask, is 36 divisible by 5? Well, if I divide 36 by 5, your calculator gives you 7.2, or 7 with a remainder of 1. That is not divisible. So this is yes, this is no. To tell if a number is divisible by another number, there are some shortcuts, some divisibility rules. Every number is divisible by 1, so we don't count 1 as being what we'll call a factor in a little bit. So we're going to start out with 2. How can we tell if a number is divisible by 2? It's an even number, yep. And just in case you're not sure what an even number is any number that has the last digit of 0, 2, 4, 6, or 8. So if that last digit is even, the number is divisible by 2. So if I have 759,374, if I want to know if that's divisible by 2, all I care about is this last digit. It's a 4, that's even, so that whole number is divisible by 2. If I want to know if a number is divisible by 3, does anybody know what the divisibility rule for 3 is? We look at the sum of the digits. What's that? Well, yeah. What is there a shortcut for telling if 3 can go into it? I had to adjust my number a little bit there to make this one work. Bless you. If the sum of the digits What does that mean? Well, that means we add up the digits. What is 7 plus 5? 12 plus 9? 21. Plus 3? 24. Plus 8? 32. Plus 4 is 36. Is 36 divisible by 3? Yes, it is. So that means the whole number is divisible by 3. And the neat thing about this is, if we're not sure if 36 is divisible by 3, well, what's 3 plus 6? 9. So 9 is divisible by 3, so that means 36 is divisible by 3. So therefore, 759,384 is divisible by 3. There is a divisibility rule for 4, but it's not terribly useful, and it's not really important. If something's divisible by 4, you can just divide it by 2 twice, and you've divided out a 4. The divisibility for 4, the divisibility rule for 4 is the last 2 digits. So let's stick with my 759,384. So the last 2 digits here is 84. Now I'm not taking each digit separately, I'm taking the 2 digits together. 84. Is 84 divisible by 4? It is. So this whole number is divisible by 4. Now the reason I say that rule isn't terribly useful is how many of you have your multiples of 4 memorized up to 100? I didn't expect any answer to that. No. Unless you have those memorized, this rule isn't terribly useful. It's just as easy to just divide out by 2 twice. And it's really easy to see that last digit's a 4, so this is divisible by 2. Technically, by the way, we're so used to talking about odd and even numbers, so when we say the divisibility rule for 2 is that it's an even number, technically the divisibility rule for 2 is that the last digit's divisible by 2. Is really all it's asking. How about to tell if something's divisible by 5? Bless you. The last digit is 0 or 5. So for this number here, the last digit's a 5, so that whole number is divisible by 5. There is a rule for 6. 6 is not horribly useful either, mainly because if it's divisible by 6, you just divide by 2 and then divide by 3, and you're going to divide out any 6s. In fact, the divisibility rule for 6 is it's divisible by 2 and by 3. So if I have 759,384, first thing I would check is 2 because that's easier. The last digit's a 4, so that is divisible by 2. And then I would add the digits up. Well, we've already done this one. That adds up to 36, so that is divisible by 3. So this number is divisible by 6 because it's divisible by both 2 and 3. Now again, I never use that rule because I would just divide by 2 and then divide by 3, and you've divided out as 6. Anybody know the divisibility rule to tell if something's divisible by 7? Neither do I. There isn't one, as far as I know. If any of you can come up with one that works every time, show it to me and I'll give you extra credit for it. And then I'll publish it, become rich, retire. Sensing a theme in today's class? There you go. Divisible by 8. Again, that's not a terribly useful rule. I can just divide by 2 3 times, and I've divided out an 8. The divisibility rule for 8 goes off of the last 3 digits. So let's say I have 973,128. We look at the last 3 digits, the 128. Is 128 divisible by 8? Yeah, actually it is. So that means the whole number is divisible by. Now again, just like the 4, most of you haven't memorized the multiples of 4 up to 100. I'm guessing even fewer of you have memorized the multiple of 8 up to 1,000. So this again is not a terribly useful rule. It's just if you're going to divide the last 3 digits by 8, you just will punch in the whole number and see if it's divisible by 8. 9 is a little bit more useful. Now again, I don't use the rule for 9 because I just divide by 3 twice. But it's the sum of the digits again. If I have 759,384, if I add those digits up, 7 plus 9, we've already done this, is 12, or 7 plus 5 is 12, plus 9 is 21, plus 3 is 24, plus 8 is 32, plus 4 is 36. Is 36 divisible by 9? Yes, it is. So this whole number is divisible by 9. Again, I don't use that one very often because I can just divide by 3 twice. How about tell something's divisible by 10? The last digit is 0. That's always the first one I look for because it's really easy to look at a number and see if the last digit's 0. In fact, I usually look for 10, and if it's not 0, then I look to see if it's divisible by 5. If that last digit's a 5, I know you can divide by 5. And then I start looking at the other rules, like 2 and 3. There are rules for numbers larger than 10, but the larger the number gets, the more complicated the divisibility rule gets. So we're not really going to look at those because I don't want to confuse you. Most of the numbers, now we talked about like the 4 and the 6 and the 8 and the 9, that we really didn't need rules for them because we could divide by smaller numbers. That's because those are what we call composite numbers. Composite numbers are made by multiplying smaller numbers. If you look at composite, like composite materials, you mix together more than one type of material. Other types of composites I can't think of right now. But like 12 is composite because it can be broken down into 3 times 4. A composite number is divisible by numbers other than 1 in itself. Those numbers that it's divisible by are called factors. So 3 and 4 are both factors of 12 because 12 can be divided by 3 and it can be divided by 4. It can also be divided by 2 and by 6. So the opposite of prime numbers is, or composite numbers, is something called prime numbers. Prime numbers have no factors. An example of this would be 13. What 2 smaller numbers can we multiply together to make 13? None. So that's prime. There are no smaller numbers that multiply. There are no numbers that 13 is divisible by. Well, it's a good thing. Now you can help her out with stuff a little bit more. These are concepts. I mean, prime and composite are things that they do teach them in, kindergarten and first grade, but they're but they're very, very powerful concepts as you get up into higher level. So the complexity of which they're applied really does grow. Yeah. Oh, cool. Well, now you owe your daughter an apology. Hopefully you didn't punish her too bad for it. No, that's not prime. You're wrong. You're going to bed without your supper. So, factoring. If we're looking at factors, factors are those numbers that it's divisible by. So if I want to look at 12 again, its factors, well, it's divisible by 2, it was divisible by 3, it was divisible by 4, and it was divisible by 6. Now somebody will usually bring up, well, it's also divisible by 12. Well, if we divide it by 12, the result would be 1. So we don't include 1 and the number itself. We don't consider them to be factors. So when we look at this, if I asked you to factor 12, you could come up with several different factor pairs. You could come up with 2 times 6, or you could come up with 3 times 4. I guess there's only 2 factor pairs for 12. The question is, how do you know which one I want? Well, there is no way to tell. So normally when we do factoring, we do what's called prime factoring. So rather than just breaking the number up into 2 pairs that multiply up to it, we break it down into the smallest possible numbers that multiply up to it. The prime numbers. So if I wanted to factor 12, if I wanted to prime factor 12, we do a factor tree. What is any number that divides into 12? Give me one. 2. 2 goes into 12. What is 2? If I take 12 divided by 2, what's left? 6. Now 2 is prime. I can't split that up into anything smaller, so I'm going to circle it. What's the number that divides into 6? 3 does. 6 divided by 3 would leave me with 2. Those are all prime. So I'm done at that point. Now I'm going to list them from smallest to largest. I have 2, another 2, and a 3. This is the way I usually write it out, is I leave it listed out like that. There's an alternative. If they want you to list out what they call exponential, all they're asking you to do is 2 times 2 is, of course, 2 squared times 3. So when they say list it out as exponentially, that's what they're asking for. I know, they have to get fancy. Right? So if I ask you to prime factor 80, we do the same thing. What is one number that divides into 80? Well, it ends in 0, so we know it's divisible by 10. If we take 80 divided by 10, what's left? 8. Is 10 prime? No, it can be split up into smaller numbers. What's a number that goes into 10? 5. 10 divided by 5 leaves us with 2. Both of those are prime, so we're going to circle them. 8, of course, can be split up. What's the number that goes into 8? 4 and 2. Okay? So the 2 is prime. I'm going to circle it. But the 4 can be split up into 2 and 2. So those are prime, so we're now done. So you do have to be careful when we list these out. How many 2's do we have to list? 4 of them. Good. So 2 times 2 times 2 times 2 times 5. Now I've listed out all the factors. What's that? It doesn't, but again, it's technically, you're supposed to list them out from smallest to largest. And again, sometimes if they ask for it exponentially, they would combine the 2's and call it 2 to the 4th times 5. Not so bad? Let's have you guys try one. Let's have you factor 72. So 72 has a lot of factors. So there's a lot of different ways you could start this out. Some of you might have started saying, oh, it's divisible by 2. It started divisible by 3 or 6 or 8 or 9 or 12. Somebody tell me what they started with. 2? 12? Okay. She was first. So if you divide it by 2, what's left over? 36. Now the 2 is prime, so we'll circle that. 36, what's one number that goes into 36? Was that? You're going to stick with the 2? Okay. You did 3? Okay. So we'll say 3. If we divide by 3, what's left over? 12. So you can circle the 3. What's the number that goes into 12? 4. What's left over? 3. The 3 is prime, so we'll circle it. And 4 is 2 times 2. So we list this out. We have how many 2s? 3 of them. And then we have 2 of the 3s. So if you left it 2 times 2 times 2 times 3 times 3, that is fine. Or you could list it as 2 to the 3rd times 3 to the 2nd. Any questions? Okay, now there is a new quiz that is due Thursday. That's due Thursday at 11:59 p.m. tomorrow. The homework is supposed to be due during class, but I always give you an extra couple hours after class in case you have to ask a question in class, so you need a little time to finish it up. But the homework's also open for like 4 or 5 days at a time. Yeah. And if you go past the deadline on the homework, don't worry about it. I'm not going to take off points on the homework if you go past the deadline. There is then a new homework. This new homework is not due until Monday. And we have not covered all the material for the new homework yet. We're going to finish that up tomorrow. Tomorrow we get started on everybody's favorite stuff, fractions.